Good afternoon everyone, welcome to G7UHN. As you can see, there's no traditional shack here. We don't have the space for a dedicated shack, so all my radio operation is set up to be run from a laptop computer, and that's what spawned some of these ideas that we're talking about remote radio. The purpose of these clips is to show the operator experience and put a bit more context around the ideas that I'm talking about in the slides. So this is the normal operating position, a laptop computer and a mouse on the dining table or wherever happens to be convenient in the house. The actual radio equipment is just a few steps away, hidden in a utility cupboard. So let's go and have a look. So here we are at the utility cupboard. As you can see, the normal domestics are below, but I've commandeered a couple of shelves in here, and this is the business end of G7UHN. Ignore the equipment on the upper shelf and this home server. What we're concentrating on is this equipment here. This is my HF radio set up to be network enabled by a Raspberry Pi 3. We have my Elecraft K2 HF radio and a power supply. The power meter's here mounted onto a jig to keep it in a fixed position relative to the Raspberry Pi camera that faces the meter needles. The RF is routed from the back of the radio through the meter up to this RF switch and then onwards through coax up to the loft antennas. To the side you can see the Signal Link audio interface, and at the back of this tray is the Raspberry Pi radio server, the USB serial interface and the relay board connected to the Pi. The equipment is stacked up on these office in trays. As you can see, space is tight. I've had to work through some RF coupling problems, but for low power operation this works for me. Okay, so let's switch it on and head back to the desktop and see how it operates. So here we are on the Linux desktop. This is Debian 9, my normal daily PC at home. We're going to look at how I normally operate the radio, which is to say local, but across the network, and then we can compare that later with how it looks in the remote experience, which is basically the same thing. So I've gathered up all the relevant controls into a GUI control panel. This is written with some Python script, which is essentially just some buttons to launch the various commands and save me having to type lots of stuff in a terminal window. This is the terminal window over here. That gives me some prompts and information as things start up. That can give me some clues if something doesn't start up properly, but really we're running the show from over on this control panel here on this side of the screen. So we can check the radio server connection. Green is good, obviously, and we're now going to select what options we're going to run up when we launch. Let's have some rig control, the video monitor on the power meter, and get some audio up and running. So let's hit the launch button, and we can see the various functions starting up now. The audio, video and serial streams have started, so let's position our windows where we want them. So we've got the control panel of my K2 over here, and that's responsive to sort of mouse clicks, scroll wheel and keyboard. We've got the video meter. This is watching my power meter here, so I can keep my eye always on those needles. This is important because I use an auto ATU, so I get to watch those meters twitching as it's hunting around. In fact, let's have a little look at that now. Let's switch up to 20 meters, and if we hit the tune button, okay, yeah, you watch the meters go crazy and then settle on a decent SWR. Okay, yeah, so that's nice. If we go back to 40 meters, then it'll probably just take a short hunt. We tune it up again. Yeah, okay, that's quite quickly back to normal. Okay, what else have we got? We've got a PTT button over here. That just fires off some GPIO on the radio server, and also the relay that I've put in line with the Signal Link's Vox output. So for data modes, I can select the Signal Link's Vox function, and then over here I've got some sort of start-stop buttons to control the various audio streams that go in and out. Okay, so with the radio functions launched and running, let's make a quick voice comms check. G4ELM, G4ELM, Golf 7 Uniform Hotel November calling.
Yep, roger, roger. G7UHN, G4ELM returning. Yeah, once again there was a short 0.3, 0.4 of a second burst of noise, and then your voice came up considerably strong.
Okay, so this is my sort of normal mode of operating. If I ever get a chance to actually operate a radio, it's typically after everyone's gone to bed, so data mode suits me quite nicely, and this setup works really well for that. So you can see we've got the audio scrolling down in FL Digi's waterfall here. Pulse Audio does an excellent job of pushing the audio across the network. It seems to be basically bit perfect, and you don't see any artifacts to do with sort of codecs or any kind of compression going on like that if you were moving audio back and forth with something like Skype. So yeah, Pulse Audio seems to do a really good job of moving the audio across the network, both transmit and receive, data modes, that's all fine. We can sort of hop around the bands a little bit. There's not a lot going on from my location at this time of night, with a lot of noise and a fairly imperfect antenna setup. So that's a look at what normal operation is for me on a Linux PC. But we don't all use Linux, and what does the system look like when we connect to it remotely? We're now going to look at how we can work with Windows, and we're also going to imagine that we're connecting remotely from an off-site location. We're going to run up the radio client applications with some help from a Raspberry Pi-like device. This is an Asus Tinkerboard connected to the PC, like a little sidecar. So the Tinkerboard has a number of advantages over the Raspberry Pi 3. It's got a faster CPU, it's got more memory, but most importantly for us, it's got a dedicated gigabit Ethernet port, so we don't suffer any USB Ethernet clashes, which can be a problem when running radio applications on the Raspberry Pi. The other big advantage of the Tinkerboard is it's got a very good onboard sound card with 24-bit 192 kHz line in, line out, so we don't have to mess about with adding on USB audio devices anyway. The Tinkerboard's the same shape and size as the Raspberry Pi 2 and 3, so it fits into a standard case, but it does run quite hot, so I've strapped a 60mm fan on top of this one to keep it cool. Connected to the Tinkerboard here, I've got a basic analog computer headset with a 5V power supply and the wired Ethernet connection to the laptop, where I'm using internet connection sharing to provide the Tinkerboard with its internet connection to the outside world. So here we are in Windows. This is 8.1. I don't spend a lot of time here. And okay, let's connect to the Tinkerboard, which is sat beside the laptop, connected via internet connection sharing and running like a little sidecar. Okay, so open up VNC. Okay, here's my Tinkerboard. Just double click on that and it pulls up the Tinkerboard's desktop. Okay, let's start the VPN, pop the password in. Okay, that's taken a little longer than usual, but that's fine. Let's see how that goes. Pop it down in the corner and start the control panel. So as before, I've got a terminal window which gives me some prompts sometimes and gives me a clue what's going on. And then over here we have the control panel. So you can see we've got our connection to the server, and now let's launch the radio. So let's launch rig control, video monitor, and start the headset audio. Okay, so you can see things start chuntering away in the terminal. That's G-Rig starting up. Okay, that all looks good. So let's minimize that and rearrange these windows a little bit. I always set this to always on top. Don't want to lose sight of that meter. Okay, And what have we got? Okay, PTT there. Yeah, that all looks okay. Right, let's give it a go. G4 ELM, G4 ELM, G7 UHN. Radio check, please.
Yeah, G7 UHN, G4 ELM returning. Loud and clear, very good quality, Andy. Some background noise, of course, as you key up from G4 ELM.
G4 ELM, G7 UHN. Yeah, terrible noise at this end. It's is what it sounds like daytime 40 meters with the indoor antennas up in the loft, but hey, what can you do? Beggars can't be choosers. But yeah, looks good at this end. Meters moving nicely. Display, and this is all running through the VPN setup. So that looks like a good test to me. Excellent. Okay, many thanks for the call.